Welcome to our final talk, but not our final activity of this session in the DSF Oktoberfest 2024. It's my great pleasure to be able to introduce Rita Neves from NVIDIA, who's going to be talking about RAG from scratch with NVIDIA NIM. Rita actually qualifies probably as a sort of rocket scientist, as her PhD's in space engineering, where she concentrated on optimizing interplanetary trajectories for asteroid retrieval. Now she's working for NVIDIA, specializing in generative AI technology, and she's focused on implementing RAG pipelines with interests in recommendations, information retrieval, and reinforcement learning. Over to Rita.
Thank you. Let me just make sure that this is all fine. Okay, perfect. So I'm the last talk of the day, I think. Hopefully you still have energy for this one. It's not going to be about asteroids, unfortunately. Maybe one day we can merge the two topics together, but today I'm going to be talking about RAG, and I'm calling it RAG from scratch because my goal here is to essentially make you realize how to create a whole RAG pipeline using LangChain and NVIDIA NIM. If you don't know what NVIDIA NIM is, I'm going to also be talking about it. I'm going to be talking about how you can use NVIDIA services for free to deploy models for RAG and very different types of models. And I'm going to be talking about what RAG is, which I believe I'm not the only talk today about RAG, so maybe you're kind of tired of listening to it. Hopefully I can bring something new, but in any case, yeah, let's give it a go. My name is Rita Neves. I've been presented already. Thank you very much. I'm very happy to be here, and I'm a solutions architect at NVIDIA. So NVIDIA is a small company that you may know, especially for their GPUs. So for a very long time, NVIDIA was well known for producing GPUs, especially for gaming capabilities, because they were the most computationally intensive things in the industry. But now, currently, we're living in what we call the AI summer, or some people call it AI summer, which means that we need compute to deploy AI models, in particular LLMs, large language models, but any kind of model will need compute to both train and perform inference. And NVIDIA provides technology for all of those areas of expertise. So basically, we can start by talking about NVIDIA Cloud. I don't really see the pointer, but if you can see it here, NVIDIA DGX Cloud is a cloud computing platform that will have the GPUs deployed online, so you can use it basically as any other cloud service. Then we have the tooling part, which means that we have a lot of open source software libraries to do the deployment of models in that compute. So basically, we have services like NeMo that will optimize the deployment and training of LLMs. We have the models themselves in a platform that we call Enterprise Search for foundational models. And we have a bunch of open source models, but also proprietary models that I'm going to be talking about later on. So all of these components are part of our generative AI offerings, essentially. And on top of that, we have a layer of expertise, which means people like me, solution architects and researchers that try to bridge the gap between what the industry needs and what we can provide in terms of services, both in hardware and software. So this is just to give a very brief overview of what NVIDIA is currently doing so far. And now I'm going to be talking about RAG in specific. So I want to talk a bit about why we use RAG and why RAG is so prevalent right now, because in the LLM space, everything moves super quickly. We're all doing things very quickly, and innovation comes very fast. So every week now, we have different models. We have new SLMs, new LLMs, continuously increasing in parameters, in number of parameters. And so it's hard to keep up with innovation as usual, but also it doesn't mean that whenever we release a model as an industry, it doesn't need always to be the model with the most parameters possible. So there's always new things to improve on for particular areas, or a trade-off to be made between the number of parameters that we are deploying and the computing power that we have to do so. So there's many things to consider when we're choosing a large language model. It shouldn't just be the model that was trained last weekend. And those things include the optimization of the model, the cutoff date for the training data, and of course, the number of parameters of the model. But this is to say that LLMs, although they are great, and again, we keep having new LLMs every week, basically. They are very powerful, but there's some scenarios where they are just not enough by themselves. So especially in cases of enterprise data, where you have a data set that will either be proprietary or will have problems of confidentiality, you generally cannot use it to train an LLM, because of those problems that I've mentioned before. And in that case, you are going to need something that bridges the gap between your data and your model. It's also not very easy for every industry to just go and train a model. The more frequent thing that we see is you take a model and you either fine-tune it for your purposes or you connect it to your enterprise data. And that's essentially what I'm presenting here. The way to do that connection between the data and the model is generally to use RAG, which is called retrieval-augmented generation, and I'm going to be explaining exactly what that means. Just to add that beyond the fact that we cannot necessarily just train, we can train a model with enterprise data, but it's generally not done depending on the data set. It's also very important, especially imagine for companies that want to yield some kind of information and have a service level agreement with the user that needs the information to be accurate, then we need to be very careful of things like hallucinations, false information, or any other misbehaviors or even behaviors regarding to an attack for the LLM. So, as I've mentioned, RAG is the thing that bridges the gap between LLMs and newer data sources, enterprise data, bigger data streams, confidential data. And so what is exactly retrieval-augmented generation? I'm not exactly sure if you in the audience can exactly see my slide, but I'm going to try to read from it a bit. So the motivation here is if you use an LLM with by itself, essentially, if you go to ChatGPT, for instance, and you ask, what is the name of that movie that Chrissy mailed me about last year? I mean, I think your expectation is that ChatGPT doesn't know your email and hasn't read your emails. So the answer is going to be something like, sorry, I don't have access to any specific information. It could also be something made up, but probably it's not going to be correct. However, if you connect that LLM to a database, which in this case is your email, God forbid. So what is the name of that movie Chris emailed me about last year? Then it becomes Chris emailed you about this movie called The Fall. So this is an example of how you can enrich your LLM with data. And so how do we actually do this is the interesting bit, I think. So here I have more or less a diagram of how RAG works, a very simple RAG model with RAG pipeline, using LangChain. And essentially, we have a bunch of components here. The first component is going to be the knowledge base, which is essentially all the data that you want to feed your LLM. It's generally composed of PDFs, but it could be videos, images. It really depends. If we take the example of enterprise data, then it's probably going to be all the documents in your company, the things that you share with your colleagues, things like that. And then the first step is the document retrieval. I'm not dealing very well with this laser. Okay. Then the first step is document retrieval, and that means how to ingest those documents. So a database, it's all very nice, and as a human, you can go and read PDFs or Word documents, but as a machine, it doesn't really work like that, especially considering that data has different formats. There's different types of inputs. For instance, PDFs sometimes come as images, and will have charts, images, tables, everything that is not necessarily standardized. So the first thing is to read that data into a common format. And that's generally done with an integrated library like LangChain, could be Haystack, could be a bunch of different solutions that are open source and available. The next step is to get all those common language documents into an embedding model, which again I cannot point to, but the embedding model is going to convert that text data into numbers, which is a very simple thing that you need to do for essentially to encode the data into a format that can be well interpreted for a vector database. So essentially you just convert text into numbers, that's fine. You save those strings of numbers into a vector database. And before that, I actually forgot to mention that first you need to split those documents into chunks. So you need to get some smaller strings of text, because imagine you have a document with 1,000 pages or even 100 pages is going to be too much. You need to split it into smaller parts so they can be then interpreted. So after that, you do the embedding, and then you store the embedded chunks into a vector database. At the same time, imagine that the user is asking something to the LLM. So the question of what was the last movie that Chris mentioned to me, then that query is also going to be embedded. And then there is a similarity metric that compares the similarity between the embedded query and the embedded chunks. And so the goal is to obtain the chunks of text that are the closest, the most similar to the query of the user. And the ones that are most closely related are the ones that are going to be fed into the LLM here in the end. So essentially what RAG does is just, it extends your context window, which is where you generally prompt it, but instead of just having the user query and the LLM prompt, which is, again, what film did Chris mention to me? You have what film Chris mentioned to me plus the information that you retrieved from the database. And that's basically telling the LLM, hey, what's the answer to this question based on the fact that you already know this extra information? And that's already a very good thing to make sure that our LLM gets to the right answer in the shortest amount of time, is what I mean. Just a small shortcut, a small sideway, to the fact that RAG can be adapted into whatever you want it to be. So you can have several different vector databases. You can have different types of information fed into it. And in particular, something close to my heart is that you can add a reranker after the vector database. And this basically means that if you don't think that doing some sort of cosine similarity between embeddings is good enough to get you the right context to the LLM, you can also use a reranker that will be probably more, increase your precision into the chunks that you're then going to be feeding into the LLM. Okay, now that I gave the more or less basics of RAG and what I want to discuss technically, I also want to talk about how you can build these kinds of pipelines with NVIDIA. And in particular, we're going to be talking about something called NVIDIA NIM, which maybe you've heard about, maybe not. It's something fairly recent from this year. And NIM means NVIDIA Inference Microservices. And the whole motivation here is training a model is hard, and for the past years, everybody's been thinking about how to train a model. But the bigger models you get, and the more you train them, the more you realize that if you have a model with billions or trillions of parameters, how are you actually making them run in production so that you can actually get results in time with low latency and actually develop something with it in a fast way. And so that's why NVIDIA developed NIMs. And NIMs are essentially a container for a model. This is a very simple thing. You have an API, you do a call to the API, and that will give you access to the model. And the model is containerized in essentially this is a visual representation of that container, which means that it will include the industry standard APIs. It will be supported for one specific model. So one NIM will be specific for one model because it is fully optimized for that model specifically. So the engine is optimized, the whole code is optimized for deployment of that model, which means that in theory, we have thousands of NIMs for the thousands of models that we have. So this is a very simple thing to use when we want to deploy models into production and when we want to experiment and develop, essentially. And just to make sure that I'm very clear, so a NIM is a container that exposes an API, and it's very clear on this diagram here that it's literally just Docker run something from our cloud, and you get the access to the model, and that's it. The model container is launched with this kind of instruction, and what happens is that the NIM detects the hardware it's running on. Of course, it's not adapted to all kinds of hardware. You need to go to the model specifically and see what's the compatible hardware for it. If you're trying to deploy Llama in your computer without GPU, good luck, for instance. It will mount the cache for the model, it will download the optimized model file, and it will load the model file and start serving the model straight away. And that means that basically in 5 minutes, you get to do something that generally in a company will take you over a week, because you generally tend to build your optimized engine, deploy the server model, and basically all of those things that we are already taking care of in a NIM. And so naturally, I think the bottom line is that when everything is optimized for you, for one specific model, the efficiency is going to be much bigger. So we have a 2.8 times improved throughput in terms of tokens for this model specifically, which is Llama 3.1 8B. So to go back to RAG almost, we have, as I've said, a NIM for each model that we have available online. I will give you the link address for you to go and check the models out. We have a very wide range of models that are both open source and proprietary, and they compose the whole range of areas of application that I have here, from text to visual to speech, healthcare, computer vision, etc. And the important things here are the retriever models, the retriever-related models, where we have the embedder model here on the left and the reranker model on the right. And they're both essentially models based on Mistral that have very good performance with NIMs, of course. And in particular, the embedding model, I don't know if you're familiar with the multilingual text embedding benchmark, which exists online. And it's basically a good set of metrics of performance of embedders, and we currently have the top one in the, well, existing in the market, which is not this one. It's still not in general availability. This is the second one. So I'm going to be actually specifically using an embed QA E5v5 in the demo part. And I can talk a bit more about that in a second. But so overall, what I want to give you an overview is that NIMs exist essentially for almost every component of the retrieval-augmented generation pipeline. I'm just talking about retrieval-augmented generation, but we do have a lot of different types of applications for NIMs, and you can already see how basically they work, because in here we have the retrieval part on the right, which includes of course, the collection of enterprise data and the vector database, which are not NIMs, but we do have the embedder to deploy the model embedder. We have the retriever, we have the reranker, and then one interesting thing that I want to point out, possibly, is the guardrails part. And the guardrails are also NIMs, and they are very important in the sense that you can, they are models also to control the output of your LLM. As you can see, they result from the output of the LLM NIM. And this basically means that you can control the hallucinations that you may have. You can have guardrails for user attacks, which is also why you have a guardrail right after the prompt. You can tailor them for every application that you can find that you need some control between what LLM to user and user to LLM, where they need to exist. So now that I've presented what RAGs are and I've presented what NIMs are, I'm going to show you how to build RAGs with NIMs. And in here, I'm going to show you some code which is possible that you may not be able to see very well from your seat, but I will share a link of where this tutorial is based, so you can find it there. I encourage you all to go and do the demo, because I personally think that it's by coding that we actually learn how things work. And also, NVIDIA provides 1,000 tokens for free when you go to build.ai.nvidia. So you can basically do your API calls, test our models, and it's very fun. So just to talk a bit about what that RAG pipeline is going to be composed of, it's exactly what I showed before. You have the enterprise knowledge base, which in this example is going to be one PDF. So it's not really realistic, but we take what we have. We are going to use LangChain for retrieval, so for document chunking and for document chunking, actually. Then we're going to embed those chunks using this model, which is the NV embed QA E5 V5, which is an adaptation of the E5 large unsupervised model that I believe comes from Microsoft Research. We are going to use Faces, the vector database, but you can use Elasticsearch, Milvus, whatever vector database. They're all integrated with NVIDIA. And finally, I'm going to use Llama 3.1 for 105 billion. Okay, so just to kind of reiterate everything that I've mentioned before, the full process for a RAG, very, very simply, is you deploy the models, the LLMs, which in this case are the embedder and the LLM. Well, the embedder is also an LLM, but this LLM is going to be for Q&A. You retrieve documents and split them into chunks, in this case using LangChain. You embed those document chunks with a model, store them in a vector database as Face. You set up the full retriever pipeline, and then in real time, you have the user give a query, you have the LLM answer based on the database. The requirements for this, and this is where I'm sharing the link to the demo, essentially, the coding demo. There's some requirements, of course, because nothing happens without a computer and without a powerful computer generally. But the first thing you need is access to a supported GPU if you're deploying models locally. You need Docker, you need NVIDIA NIMs, you need a Python version that's slightly high in Python 3. And the big thing here is that you need an NVIDIA developer account if you actually want to deploy models from our catalog. And this literally just means that you go to the page on the right, which is build.nvidia.com. You then click on the user thing, and you're greeted with this login to start building with NVIDIA NIM. And if you use your personal email, you'll get some credits to use NIM. You can self-host them on your infrastructure, and you also get community support with developer forums. So essentially, you have all the tools to play. And now so just to reiterate, this will give you access to API keys that are then used to connect to the APIs and do auth, of course. And now, finally, I'm just going to show code, which is a bit dry. I apologize for that, but to be honest, for me, it really helps to see how complicated this is, because in the end, it does seem like a lot of steps. It's a fairly state-of-the-art application, meaning talking about RAG, but it can be deployed in probably something like 30 lines of code, and that's always interesting to see. So first, of course, you're going to need to add your API keys and call the model. And this is very simply by using, in this case, we use a LangChain endpoint. Again, you could use a Haystack endpoint. We work all the time with open source libraries for this. Then, setting up a basic QA pipeline. This is very similar to what I showed with the example of the movie. So in this case, again, you're using LangChain, and you're building a chain with a prompt, the LLM that we've called on the previous slide, and of course, a string output parser. But in this case, the only thing you need to do is to define your prompt, and it's going to depend on your application. In this case, we do a very regular Q&A prompt where we say, hey, be nice, don't say anything wrong, and reply to the answer, reply to the question that you're made. Generally, you are a helpful and friendly AI. I never know if this works very well, but. Then you ask it a question with chain invoke. And the question is, what's the difference between a GPU and CPU? And I'm sure that all of you could reply to this, and the LLM also can. So it's going to say something like, a CPU handles general computing tasks, whereas a GPU specializes in graphics and compute-intensive tasks. So very well, very good. But then if you ask it something a bit more specific, which is, how much memory does the NVIDIA H200 GPU have? The answer is, I don't have information on the NVIDIA H200. Probably not, none of you have it as well, so it's also something in common. What do we want here? We want to make sure that this LLM has the information about NVIDIA H200. And of course, with that, we're using RAG to add that document to the pipeline. So let's now start with the RAG process. This is definitely not RAG. This is a QA pipeline. There's no documents. There's no database connected here. If we want to build the pipeline, as I've mentioned before, we need to call an embedder. And an embedder NIM is very simply, as I've mentioned, a Docker run for a container, which has a container name that you, of course, need to take from the website that I've mentioned before. You need to specify the runtime, the GPUs, and very importantly, the API key that you also obtain by the website. Oh, and this is fun. I forgot to put animations on my arrows, but let's pretend I didn't. And so after you have your embedding model running with Docker run, you are free to do the API calls that you need. And therefore, you can start with the retrieval process, which is, as I've mentioned, getting documents, chunking documents, and embedding those. So in this particular case, we get this document that is a data sheet for the H200. We load the document with LangChain PyPDF loader. We split the document with text splitter. In this case, we split the document into 8 chunks. We put them into the face data store. We call the NVIDIA embedder at this URL that we've deployed and obtained before. And we get all the embedding chunks. Now, of course, this all looks very simple, and it is. But if you want to optimize your RAG process, of course, you need to consider how many chunks you should have, of course. How are you splitting those chunks? Because chunking is a very mathematical operation. You have a document, and you say, I want a number of tokens per chunk. And that's all very fine, but sometimes when you're splitting documents like this, you're missing the context from one chunk to the other. So this is something that I just am warning you about, that sometimes the number of tokens you put in each chunk is going to affect the result of your RAG pipeline. And so you need to deeply consider this, as well as what your context window is for both embedding and LLM. So finally, we have a full RAG working pipeline, and this is going to be where my talk ends. Essentially, you have exactly the same thing as you had before, which is a prompt. where you have, again, you are a friendly AI and do not hallucinate, which is a very stark order. And the very big difference here is that in LangChain, for you to code drag up, you are adding a context, which is the vector store as a retriever. And so it's basically building the whole chain, connecting to the embedded chunks that are already available in the vector database from Face. This is very simple. Essentially, this whole thing is going to give you the RAG pipeline without a reranker, just with an embedder. So in this particular case, and you'll have to trust me on this because I don't have a live demo, but you can fully trust me. You can ask how much memory does the NVIDIA H200 have? And the response is now, the NVIDIA H200 has 141 gigabytes of HBM3E memory. And this is correct. Also, you're going to have to trust me on this, although I've shared the link. So you can see how easy it is to code things up with NIMs, how easy it is to get a pipeline that will essentially make it so that you can improve your LLMs with external data knowledge, and essentially fulfill your dreams of building data-enhanced pipelines. That's it. I'm leaving some resources, which I don't have the links to, but if you search the words, you can essentially find them. We are very focused on RAG at NVIDIA because we do see it as a very good alternative to just using very, very large context windows. We do know that it's very useful for a series of purposes, of course, with enterprise data, as I've mentioned before. And yeah, that's it. Hopefully you've taken something from this presentation, and thank you for your attention.
Thanks, Rita. We've got time for some questions.
Yeah, thank you very much. Really interesting presentation. My experience with RAG is that, what you've just described there sort of works. I think some claim that the plain vanilla RAG approach is like the naive approach, but then depending upon how you do the retrieval, you have all sorts of variant ways of doing the retrieval. Just wanted to get your advice on some other ways of trying to get better results out of RAG, and then also one other thing. Could you also provide some advice on how to sort of estimate performance of inference results? Post RAG, you've now got this RAG thing, and then now it's spitting out inference results.
Yep.
How do you actually measure how well it's performed?
Okay, so these are two very interesting questions. The second one I can answer a bit better than the first one, because when we talk about advice towards making RAGs more efficient, like with everything connected to machine learning, it's going to be dependent on your application. There's always a trade-off. There's no free lunches, as people say. So the best thing is always more compute, more data. But of course, you may not have that compute, or you may not have a requirement for latency that allows for that compute. In general, in my experience, I'm not super familiar with the different chunking part. I do believe that if you want good recall, you have to try to have a good balance of how many chunks you're giving the LLM and essentially the context window of the LLM. And in my experience, that's always improved by adding a reranker. So just having a cosine similarity metric is generally not good enough because you're missing on the context of the rest of the document. And so feeding the text directly to a reranker is generally much better, although there's still a lot of work going on to make this more precise. So I don't think it's the end-all be-all. I think there's probably going to be a lot more work towards finding the right context in the database to feed to the LLM, and we're not quite there yet. Now, to talk about metrics and evaluation, I think that's very interesting because the current data sets that exist for Q&A are generally multiple choice. So you have something like, you have a question that has 4 options, and then the LLM just needs to answer A, B, C, or D, and that's very easy, right? You can say that's correct or that's wrong. But if you have something like, if you're evaluating an actual large question that doesn't have any options, then you need to think, am I going to try to go for some NLP metric like a blue score? And that's something that I've done in the past. Or using recall in the sense that you know exactly the chunks that you need from the text, and you then go and compare and see if they went into the context window. That's also something I've done in the past, and also seeing what like the NCGC, I'm forgetting the ranking metric for the ranking position of the chunk in the vector database as well. It really depends. It depends if you're ranking the answer from the LLM or from the position of the embedding in the vector database. But in general, yeah, there's a lot of work to be done in that. I will go for NLP metrics for the LLM part and ranking metrics for the vector database.
Hi, thanks for the talk. I was wondering, you mentioned that over here,
yeah.
You mentioned that the end user would have to meet some hardware requirements to run the container.
Yeah.
So I was wondering which parts of the pipeline would be running on the end user and which ones would be running behind the API, and what kind of policy for data flowing from the end user to the API would the system be following?
Okay, yeah. So when I've mentioned the hardware requirements, they will vary by NIM. So depending on the model that you're running, you'll have different hardware requirements. And in this in particular, I believe I have this table here. So for instance, for the one on the this embed QA Mistral model, I think it requires just, for instance, a regular GPU, whatever GPU you have, but it needs to have 16 gigabytes of memory. And the one I've deployed in the pipeline that I've demoed, you only need 2 gigabytes of memory, for instance. So you need to see the specifications. But I think your question relates more to how you're deploying the NIM. And so there's 2 ways. You can do an API call to something that's already hosted on the GX cloud, which is the NVIDIA cloud, or you can deploy it in your own computer. So basically, you do a call where the model is copied into your own infrastructure, and then you work from there.
Thank you very much. Very interesting talk. I wanted to understand that the data that we have, like you divide the PDF into chunks. If the PDFs are made up of tables sometimes and some of text, and you also want to incorporate organizational databases as well, so 2-3 types of information.
Yep.
So how do we chunk them? Do we? What advice do you have?
Yeah, so that's very interesting because I do feel like full disclosure, I don't have a lot of experience with that area because I feel like it's something that's basically starting right now connected to RAG, starting in terms of in the sense that there is no very well-developed solutions. It's something that I talk to people quite a lot regarding the fact that ingestion of PDFs, especially as images, is quite hard. In NVIDIA, we're developing essentially a NIM to do that ingestion, and that's basically a group of services that will deal with tables separately, charts separately, images, and text from PDFs. So it's not a one-fits-all solution. You need to have the specific components for this. And what these services do is essentially just convert each specific component already into an embedded result. And therefore, what you have, you're basically chunking the table as a one thing altogether, and an image as a one thing altogether, as far as I know. But can you please? Yeah.
If you wanted to like incorporate the databases that you have within organization as well, within.
databases that are not made of PDFs, for instance.
Yes.
Yeah, so I do feel like it really depends on the ingestion procedure. There's a lot of enterprise databases that will have different connectors like, I don't know, Jira Pages, Confluence, things like that. And so far, we don't necessarily have a very good solution for that. I do know, and I'm working with different companies that are studying that, but I'm not really able to give an answer of those things.
I'd just like to add into that I think with yourself and the products you have, a lot of the providers have, because the language models take the words that would be in your database record. So if you have an address, if you have personal details or particular bank account things, particular patterns, when it goes into the vector database, it will associate regardless of the source. So as it reads in that data, it embeds them into an embedding, which will be LangChain's embedding. So if you have somebody who has their LinkedIn profile with their email address and their business account with their email address, when you read both of those data sets in, because the email addresses are the same, that will go to a particular point in the vector database. And then when you go look at the vector database for that address, when you take the email address back, you will get the profile and the account details coming back in the response.
Yeah, essentially, just to add to that, the RAG itself is separate from the ingestion process, and the ingestion is going to be specific to the enterprise data that we have, and therefore there's not a one-fits-all solution, because you may have to deal with issues of confidentiality, of email addresses. The data needs to be treated in according to the requirements of the company and the service that's providing.
Okay, I don't think we have any more questions, so let's thank Rita again.
Thank you.